6 today in Advanced Algebra 2. Pretty simple stuff. We're going to take a base to a rational exponent. We're also going to rewrite some of this stuff. Rational exponents, here's what it's all about right here. It says if you've got like b to the 1 over n power or any kind of rational, the exponent is a fraction, right? It's rational exponents. You got a fraction for an exponent up there. It's power over root is how it is. We've been kind of talking about it the past couple of days. Power over root. Well, it says anything that you got as b to the 1 over n, that's the same thing as saying it's the nth root of b. Isn't the base b both times in this situation? Power over root, n is the root right there, right? It's whatever that little index is, and there's your first power right there. It's like power over root kind of situation. There's only a couple of restrictions. They say the base has to be positive, or I should say not 0. Let me try that one more time. The base has to be non-negative, right? It could be 0 and it can be positive if this is an even root. For example, do you have an even root? Yes or no? Yes. That base underneath there, isn't that negative? Can't do it. You can't take a fourth root of a negative base. So what we're doing here is we're just rewriting these. And if they have a rational exponent, we're going to use a radical. If they have a radical, we're going to change it to a rational exponent. So our base is x, correct? We're going to put a radical around it. If you got it to the 1/6 power, 1 is the power, 6 is the root. Power over root. So which root do we have right here? 6th root goes right there for an index. And then it's like to the first power right there, which you really don't need to put that 1 in there, but that's where it really goes. It's the base to this power, and there's our root right here. So over to number 2, don't we have a rational exponent? We want to write it with a radical. So base a, here's the radical. What's our root in this situation? Is it the 1 or the 5? 5. We got the 5th root of a to the first power. So far, so good. Number 3, we've got a base d. Since it's a rational exponent, we're going to write it with a radical. I got an rational exponent of 4/7. Which one's the root, the 4 or the 7? Because it's power over root, so you put the little 7 up here on the index, and then the 4 has to go in here. It's d to the 4th, and then you take the 7th root of that situation. Try number 4 for me, if you would. Rewrite that with radicals. Should be the cube root of t squared. Feeling pretty cozy with that. They gave you a rational exponent. We wanted to write it with radicals. Now we go reverse. They give us a radical. We want to write it with a rational exponent, so it's always just power over root. This is a z to the, what power would we do, baby? 1/4. Power over root. Over here, what does that say right there? Is that an 8 or a 3? That's an 8. Okay, so we got c to the 8/3 or 3/8? 3/8. Power over root. It's just a little phrase to remember. Keeps you out of a jam. Power over root. Base of negative c. Since the base is negative, you want to put it in parentheses, right? Whatever that's underneath that radical symbol, just make it a quantity. And then we go to the 1/3 power. Can you take a cube root of a negative underneath there? Can that happen? Yep. And finally, interesting. So easy that it's hard. W is the base, and what would we raise it to? First power, second power. I need power over root. Here's the power, correct? What's the root? Root is 2, correct? So what power do we have right there, my friends? To the 1/2 power. Does that make sense? Okay, cool. Power over root, power over root, power over root. So for you people out there in video land, Mrs. Colwell typed out instructions of how she wants these done. That's great. It's all good. I like to do it in a different order. I feel that what she does last is something that I would like to do first because it's the most forgotten thing ever. So if you're my student, I'd like you to cross these instructions out and write these 4 things down. If you're a Colwell person, then do just like what she says in this order. So please pause the video and get that done. Now, here's what we're going to do. First thing we got to realize is check for an even root and a negative base. Okay? Here's our first problem. Doesn't that say 81 to the negative 1/4 power? Correct? What's the base out of that situation? 81. Is the base negative? Yes or no? No. Because we're looking to see, isn't the root of 4? We're trying to see, are we taking the 4th root of a negative base at all? We are not doing that. Isn't the base positive? Correct? So since the base is positive, we pass the first check right here. We're good here. Step 2, if the what is negative? If the exponent is negative, you should reciprocate the base. You were taught that in algebra. You may have forgotten it, but that's all that the negative exponent means, is take this base right here and reciprocate it, aka flip it over. What's the reciprocal of 81? 1 over 81. So here's what we'll do. We'll do a little rewriting. 1 over 81 is the entire base. And now it is raised to the positive 1/4 power. That's all that negative exponent meant, was reciprocate the base. I have used that exponent by flipping that base upside down. Cool? Now we've done this. We do the root first. You always want to do the root first. What roots do we have in this situation? Since we have power over root, what root do we want? We need the 4th root of 1 over 81. So let's do that. Do you know what the 4th root of 1 is? It's 1. Do you know what the 4th root of 81 is? It's 3. And then you'd be left with that entire base to whatever power is left over. It just so happens that the power in this case is a 1, so we're like done with this problem right here. We're trying to just figure out what is 81 to the negative 1/4 power. It turns out to be 1/3. Just takes a little practice. The more we do, you'll be like, this is the easiest thing ever if you know those numbers on your perfect note card. This guy, first thing you check, is the base negative, and do you have an even root? Do we have any of that going on here on number 10? Nope. So the next thing we check for, look at your exponent. Is your exponent negative? Yes or no? Nope. So then we move to step 3. Let's take the root. Do you know the cube root of 216? It's 6. And you're still left with that power, right? All we did is we used this little guy right here. We used the cube root. Is everyone cool with the cube root of 216 is 6? And it's now left to the 2nd power. When you're doing this, I want to see that, okay? I don't want any of this all done in one step. They're multiple steppers. I need to see 6 squared. Then 6 squared is how much? And that's our final answer, so we circle it. This is all non-calculator test type of questions. Do you know what's going on with this exponent? Cool. Let's try number 11. According to the order of our checklist here, check for a negative base. Do we have a negative base? Yep, but that doesn't mean anything. It's also, you have to have an even root with this situation also. Do we have a negative base with an even root? So that means can't do the problem. You cannot take the square root of negative 36 in the real number system. You with me on that? It's just like if I wrote this. Can't do it, right? It's not in the real number system. Good with that? How about 12? Do we have a negative base? So we can move on to step 2. Do we have a negative exponent? Nope. Time to use the root. That's a 3. 8. 8. 8th root of 256. Holy cow. Take a guess. 2. That's something we're not expecting you to know, so let's punch it into calculator and double check. If you took 256 to the 1/8 power, what would you get? Punch it in real quick. So we punch that puppy in, and 256 to the 1/8 power is 2, so we're left with this. We've got 2 to the 3rd power. Correct? Isn't that a 3 upstairs? It's hard for me to read that little scrunchy deal. And what's 2 cubed, baby? 8. 13. Check step 1. We've got a negative base, right? What root are we trying to take, even or odd? Can you take the odd root of a negative base? Well, let's do it. What's the 5th root of negative 32? Negative 2. Keep it in parentheses. And then that power of 2 is still there, right? Now we got to square negative 2, and what do you get? 4 or negative 4? You get a positive 4. Pretty cool? You and Pal on 14 decide if we can do it or if we can't do it. Can we do number 14? What do you think? Yes or no? The answer is yes. A lot of people see that negative, and they're like, oh, you can't do it. You got an even root and a negative. It's not a negative base. It's a negative exponent. So we can do it because the base is positive. Now let's use the negative exponent. Negative exponent means reciprocate the base. So what's the reciprocal of 49? 1/49. Put it in parentheses, and it's still raised to the positive 1/2 power now. All the reciprocation did was get rid of the negative part of the exponent. Now, when we square root this puppy, what's the square root of 1/49? 1/7. It'd be raised to the first power, and we are done. Boy, if you know these numbers, there's a piece of cake, isn't it? Yeah. Try 15 then. Try 15. No negative base, right? Don't have a negative exponent, so I don't have any reciprocation going on. I just need the cube root of 343. What's the cube root of 343? 7, baby. 16. Give that one a shot. No negative base, so I can do it. I do have a negative exponent, right? Does that say negative 1/5? Okay, so that means I need to reciprocate the base and raise it to the positive 1/5. Now I need the fifth root of 1/32. Well, the fifth root of 1 is 1. The fifth root of 32 is 2. And it'll be raised to the first power, which I don't need to write down, so done with that. 17, no negative base, so we can do it. No negative exponents, no flipping. What do I do first? Square the 125 or cube root? Because honestly, it doesn't matter. But if you were doing this with no calculator, what would you like to do? Take 125 and square it and then take the cube root of that number? Or would you like to take the cube root of 125 first? Always do the root first. What's the cube root of 125? 5. Put the squared there still, and then 25 is our answer. Pretty cozy on those. Check out the next one. Can't have a rational exponent downstairs. Here's why. It's like you're really saying this. This is the same problem. Isn't that the same problem right there? That 4 to the 3/2. Do you see how you have a radical in the denominator when that happens? Right? Can't have it. So let's just kind of see if this cleans up a little bit. Base is positive, right? So I can do it. Let's take the square root of 4. What's the square root of 4? So this is really 24 over 2 cubed, right? And do you know what 2 cubed is? So you really have 24 over 8. And can that reduce at all? That's 3, baby. Yep. Pretty simple. Yes, ma'am. So over here, again, the main rule, put a box around this. You got to have, it has no exponents that are non-positive integers in the denominator. For this to be simplified, no exponents that are not positive, magic word is integers in the denominator. Got to be an integer in the denominator. Can't have a rational exponent in the denominator. Just like you can't have a radical in the denominator. It's the same concept. So this is same base. What would you do with those exponents, my friends? If you had a squared times a cubed, what would you get? A to the 5th. What did you do with those exponents? Add them together. Let's add these. Oh, they're fractions. Well, by God, do they have the common denominator? So this is really a to what power? 6/7. Is that a good answer? Do you have a rational exponent in the denominator of this? Here's the denominator. Do you have a rational exponent in the denominator? You do? It looks to me like there's a 1 in the denominator. Do you have a rational exponent in the denominator? Yes or no? Holy crap. This is an exponent. Isn't it a rational number? Correct? Is that upstairs or downstairs? That's called the numerator, correct? Do you have a rational exponent in the denominator? Yes or no? So that's a perfectly fine answer. You cannot have a rational exponent downstairs. You can have one upstairs. Are we cool with that? Let's try 20 here. Do you have Same base of y, yeah. Common denominator also. Let's add those together. What do we get right there? 4/5. Is that a good answer? Because you don't have a rational exponent downstairs. It's all upstairs right here. Cool. That's a perfectly fine answer. Cool. How come we're not like doing the 5th root of it and all of this stuff or that, the other? Because the base is not a number. It's a variable, right? It's base y. The other thing that this should say up here that I should really make a note, write the simplified expression in the same form as the beginning expression. That means, did they use rational exponents in this problem? Then your final answer should be rational exponents. No radicals involved. If they start with radicals, you should end with radicals, right? If they start with rational exponents, you end with rational exponents, okay? Next one. Ooh, base b. There's something that can be cleaned up in this, though. What can be cleaned up? There's a negative exponent. You can't leave any final answers with a negative exponent. So what does that mean we got to do? Reciprocate the base. That'd be 1 over b to the positive 5/6 power. Right? Everyone cool with me so far? Then I could tell you what that turns out to be. 1 to anything, any power itself, is going to be 1. If you did it, you'd take the 6th root of 1, which is 1, raise it to the 5th power, and you'd still get 1, right? Isn't 1 to the 5/6 power still going to turn out to be 1? And this is going to be b to the 5/6 down here, right? If this is b to the 1st, you take it times, you multiply those exponents. 1 times 5/6 is 5/6. Y'all with me on that? Yeah? No? Maybe? Cool. Is that a good final answer? No, because we have a rational exponent, and where's it located? Downstairs. So here's what we need to do. We need to rationalize it by taking it times. Let's see if you can figure it out. Why did I choose 1/6? Why did I choose 1/6? When you multiply b to the 5/6 times b to the 1/6, wouldn't you add those exponents together and get b to the 6/6, which is what, really? B to the 1st power. You see how I just got rid of the rational exponents? With me on that? What's upstairs, though? B to the 1/6. And that's the final answer. Cool? I'll show you this in radical form just for fun. Isn't this really b to the 5th, and we're taking the 6th root of it, correct? And didn't I multiply it by a 6th root, and I took it times b to the 1st? Didn't I want to get a b to the 6th shooting out of that situation, just like we were doing before? But in this case, it was rational instead of radical. Let's try the next one. Got a negative exponent. Clean him up. You can also do the old change of house rule if you really wanted to. Isn't that negative exponent upstairs would just come downstairs in the first place because he would change houses? It all works out to the same thing if you took it as 1 over r to the positive 4/5. I guarantee you, you will get 1 over r to the 4/5 out of that situation, right? I just changed houses with it instead. Same concept. Cool? Problem though? Got a rational exponent downstairs. So I will rationalize him by taking it base r to what power, my friends? 1/5, both up and down. And then you get r to the 1/5 over r you going to the mall today, Billy. It's been a while since I said that one. That's from Billy Madison. Look it up, 1995. Great year. We cool with that? Awesome. Just a few more. Simplify each expression. No calculator. Go for 23. You already know how to do that one. Go for 23. Pause the video, get that one done. So, 16 is not a perfect cube, so I'm going to split them up into 2 cube root radicals. Doesn't 8 go in there twice? How many x's can come over here on the perfect side, my friends? Shwee of them, and 1 left over there, correct? This side over here is mighty perfect. You get a 2x when you cube root it, and don't you get the cube root of 2x underneath there? All right, go for 24. No calculator. We got to get better without the calculator. How about 4z squared? Isn't 64 a perfect cube, correct? Isn't z to the 6th the perfect cube? Because power over root, doesn't that come out to be a integer instead of a rational number? Rock and roll. New stuff here. Do you see we got bad news bears here? We have a rational exponent downstairs. It's just like having a radical in the denominator. You can't have it. There's also more than one term down there. So we need to rationalize this by multiplying by the, starts with a C, conjugate of the denominator. What is the conjugate of the denominator, baby? 3x to the 1/2 minus 2. Let me put this in a bigger window here so we can actually see what's going on. So we'll make this guy a quantity, with a pen, times 3x to the 1/2 minus 2 over itself. Make the other guy a quantity. Denominator, piece of cake. The denominator are conjugates of each other, right? It's the same thing as doing this. Doesn't this guy really say the square root of x right here, correct? Don't you take number times number and radical times radical, correct? Let's do it. Number times number, what do you get? 9, and x to the 1/2 times x to the 1/2 will turn out to be what? X, right? I mean, think about it. Don't you add those exponents together, right? Isn't 1/2 plus 1/2? And they turn out to be 1, right? So you have 9x out of that situation. Being how these are conjugates, won't the inside and outside terms just totally cancel each other out? Last terms times each other is minus 4. Groovy? Let's spoil the upstairs, though, since they're not conjugates. 3x to the 1/2 times 1x to the 1/2. So numbers times numbers, you get a 3, right? X to the 1/2 times x to the 1/2 is x. With me on that? Outside terms times each other, minus 2x to the 1/2. Right? Outside terms, negative 2 times x to the 1/2 is minus 2x to the 1/2. Inside terms times each other, what would you get? Minus 6x to the 1/2. Correct? And then the last terms times each other, you'd get plus 4. Cool. I don't want to go too fast. Is that all right with y'all, where that came from? Any like terms here? Any like terms there at all? So how about 3x minus 8x to the 1/2 plus 4 over 9x minus 4 for a final. We don't need to restrict our domain or anything like that. You don't have to say x is not equal to 4/9. This is not an equation that we're solving or anything like that. It's not a graph that we're graphing. We are just simplifying a expression right here. Yep. Next page. Hey, man, I'm done. It's all you now. We're going to do it groups of 4s. Okay, so I'm going to talk to the video people. All you people out there in video land, don't quit on me right now, because there's more new material at the end of these, like this entire page right here. But it's going to be quick and sweet. Do 4 at a time, then come back and check. Then do another 4 and come back and check. So do these 4 with the video paused, then check, then do the next 4 and the next 4 and the next 4. Ready? Go for it. Because those 4 should be pretty quick. This is the square root of 9. This is the cube root of 8. This is the 4th root of 16. This is the square root of 36. We're doing these 4 maneuvers. Check for an even root to see if it can even be done. Then if there's a negative exponent, we'll reciprocate the base, take the root, use the power. You cool with what we're doing? Next 4. Go for it. In 31 through 34, are there any of them that we can't do? What do you think? Any empty set kind of deals or undefined? All the bases are positive, correct? So we can do them all, right? Here's what you should have got. 31 needed no real work to show. 32 needed no real work to show. 33, we needed to reciprocate that base. And then you take the 4th root of 16 and get 1/2. 34 was a lot of work. You had a negative exponent. You should have reciprocated it. It's to the positive 2/3. Then cube root each thing. You get 10 over 4 in the quantity. It's still being squared. I went ahead and reduced 10/4 before I moved on. Doesn't 10/4 reduce to 5/2? Then I squared it and got 25/4 for a final. 4 more. First one had a negative base and an even root. That's a no dice. Everything else was doable. I got a question for you, though, before we get too deep into this worksheet. On number 37, what's the base? Is it -8 or is it +8? The base is +8. If the base was a -8, it'd be in parentheses, right? That's something that we just don't understand. We haven't done enough of those yet. The base is what's being raised to the 1/3 power. And right now, this really says this. It says, please take 8 to the 1/3 power, then take it times -1. Because look at these two problems down here. Boy, oh boy, they look exactly the same, don't they? But they are not exactly the same. So when we do the next 4 problems, pay special attention to what you think is supposed to happen on those. Okay? Give them a shot. If the base is negative, it will be in parentheses. So I want to kind of go out of order. What do you think about 39? Can't do it. Negative base, even root. Correct? Jump over here. 42. Let's skip these for a second. Can you do 42? Yes or no? Yep. Got to do a little bit of this, though. Why am I doing this? Negative exponent. 4th root. Looks like that'd be 1/5, baby. Correct? To the 3rd power, which is 1/125. Correct? Now, let's watch the magic happen on this one. Tell me about 40. Is the base negative? Yes or no? Yes. Can we do this problem? Yes, because even though the base is negative, isn't the root odd? Correct? So I need to take the cube root of -8, which is -2, and it stays in parentheses. 2. And what's the power this is still raised to is the 2nd. What's -2 squared, my friends? 4. You have to show that. Yes. Yes, yes. If you are doing this all in your head, I would probably put a big fat F on that non-calculator test. You with me on that? I want to see each little step. Sound cool? Done. Next guy. Base, negative or positive? Positive. But see, this negative, he's going to come along for the ride. Don't I need to take the cube root of +8? What's the cube root of +8? 2. And it's being squared still, but that negative hasn't disappeared yet. Correct? Now I need to square what? What do I square? -2 is not the base. What's the base? 2 is the base. Square 2. What's 2 squared right here? 4. And that negative, he's still there. The final answer is -4. It's all about parentheses. If the negative is inside parentheses, then it stays with the base. If it's not, it's just going to be at your final answer. That's just going to keep coming on down for the ride. 4 more. Go for them. The trickiest one is the first one. Tell me about the base on number 43. What's the base? It's a +100. It's a +100. See that negative? Not in parentheses. We can do the first one. You take the square root of 100 and get 10 and bring the negative down for the ride. All right? It's all about parentheses. Here's the rest of them for you, just to check yourself. 4 more. Check yourself and then keep moving on. Oops. There's your next 4. Do all 16 of them now. If you're in video land, there's 16 left on the 3rd page here. Get them all done, check them. Then we'll do those last 6 problems together. There's 8 of them for you, video people. Someone said on a problem like this, is like, if there's a negative that's not in the parentheses, will the answer always come out negative? Maybe not. Because what if this was like to the 3rd power or something like this? Like you take a negative to an odd power, it becomes negative, then you got to take it, like, give me one, I'll give you one right here. Negative 2 to the 1/3, wow, let's put an 8 there. Negative 8 to the 1/3 power. Well, I guess the base is always positive, so yeah, it will always turn out negative, right? It will always turn out negative, because if this is the case, then the base is positive all the time, right? So yes, if there's a negative not in parentheses, then the answer will always come out negative. Okay? Next. No calculator. Same base, right? What do you need to do with those exponents? Add them up. Nemesis. What do you have to add fractions? So I'm going to go off to the side. I'm going to say 3/4 plus 1/2, right? And I'm going to rewrite this with the denominator of a 4. So don't you just take everything times 2? Isn't 1/2 really 2/4? You with me on that? I'm just trying to add these denominators together. What's 3/4 plus 2/4, baby? 5/4. So this is really a to the 5/4. The question is, can you leave that for a final answer? Because that rational exponent is located in the numerator, which is okay. Cool? Over here, you don't really want to do the old where are there more game. I mean, you might be able to do it, you know, if the denominators are the same. But if not, you know, I'd just say do the real rule of subtract the exponents from each other. We want to do 4/5 minus 1/5. Oh, do those have common denominators? So we really have 3/5 for our exponent. And since it came out positive, it's upstairs. Yeah? Everyone cool with what I did? Subtracted. If you wanted to play where are there more, if there's 4/5 upstairs and 1/5 downstairs, aren't there 3 more fifths upstairs than there is downstairs also, correct? Right. Next one. Yikes! Yikes! B's. B's. You got some B's upstairs and some B's downstairs. Subtract the exponents from each other. Let's take 3 minus 1/3. I need a common denominator, so I'll let you get that for me. 3 minus 1/3. Isn't this really 9/3? Right? And 9/3 minus 1/3 is how much? And since 8/3 is a positive number, right, the exponent came out positive, that means he's upstairs. Right? If you ask yourself, where are there more right now, aren't there more B's upstairs? There's 3 of them upstairs and 1/3 of them downstairs, right? So there is 8/3 more up there. So B to the 8/3. C's. Where are there more C's, upstairs or downstairs? And if you want to subtract, you do 1 minus 1/2. I'll bet you can do that mentally. What's 1 minus 1/2? It's still 1/2. So don't you left with C to the 1/2 power. Does that make sense? What I did right there. Common denominators. Adding if you're doing a product of powers, subtracting if you're doing a quotient of powers. 7D, go for it. You've got a rational exponent downstairs with a binomial term. Multiply top and bottom by the conjugate of the denominator. We did one on the front page or middle page. I don't know where we did it, but we did one earlier. Give it a shot. Should be multiplying by m to the 1/2 minus 4 on top and bottom. Conjugate of the denominator. When you take m to the 1/2 times m to the 1/2, you add the exponents together, and last I checked, 1/2 plus 1/2 is 1. Right? So that's m outside terms minus 4m's to the 1/2, inside plus 5m's to the 1/2, and minus 20, all upstairs. Like terms, Done. Cool. What do we got left here? Why don't you try 71 for me, and then we'll shut her down after that. If we can get 71, we'll shut her down. 45 is the common denominator between them. Easiest way, if you don't know, is just do the old switcheroony. Take this times 5 over 5, take this times 9 over 9, and then you get 35 45ths minus 9 45ths, and then 35 minus 9 is 26 45ths. Is that right? Cool. So a to the 26 45ths. Yep. All right.